So dispersion is the splitting of white light into the visible spectrum. And we'll come back to what that means in a moment, the visible spectrum. But dispersion essentially is when we take white light, we usually put it through a prism, a triangular prism, and it splits up into this spectrum, also known as the rainbow. And the thing about dispersion, why it's so important, is that it proves that white light is simply a mixture of coloured light. In the past, they thought that white light was pure and that coloured light wasn't, but Isaac Newton, along with other people, managed to prove that white light is actually just a mixture of all the colours together. Now, why does dispersion happen? Why, if I put some white light through a prism, does it split out into this rainbow? Well, it's all due to something called refraction. And refraction is the bending of light as it travels through different media at an angle. So the white light is travelling through the air, and when it hits the glass, the white light bends. Now, the colours in the white light all bend a different amount. And if you look at this diagram here, you can see that the red light bends least. So here we have refraction, because the white light is going from air to glass, and then it happens here as well when it goes from the glass to the air. And all the red light in the white light bends the least. Now, if it didn't bend, it would go like this. The red light is bent a little bit and bent like so. So the red light bends the least, or refracts the least. That's a proper way of saying it. Whereas the purple light, you can see the purple light bends a lot more. So the violet light at the bottom bends or refracts the most. And the other colours in the spectrum, they bend by varying amounts. Now, you should know these colours. They're the colours of the rainbow. We have red, orange, yellow, green, blue, indigo, violet. And in this order, these make up something called the visible spectrum. And the visible spectrum, like any spectrum, is just a range. So spectrum means a range, and it's the range of electromagnetic radiation that humans can see. Hence why it's called visible. So you might have heard of the electromagnetic spectrum or electromagnetic radiation. In the middle of that, we've got the visible spectrum. It's part of the EM spectrum, and it's the part of the EM spectrum, or the range of electromagnetic radiation, that are visible to human eyes. There are other parts of light that we can't see. So just above the red here, there is something called infrared. That's red that's more red than red, and we can't see that. And just below violet, we'd have ultraviolet, which is light that's too violet for us to see, hence why it's called ultraviolet. Now, why do we have these different colours? Well, colours of light, the colour of light, depends on two things. It depends on the wavelength of the light and the frequency of the light. Because light is a wave, so it has a wavelength and it has a frequency. Now, red light has got a long wavelength and a low frequency. So red is long wavelength and it has the symbol lambda, and it's got a low frequency. Whereas purple light or indigo light, or even violet I should say, has got a much shorter wavelength and a higher frequency. So hopefully you can see here the wavelength, which is this length there, the wavelength here, this wavelength is much shorter. And that's the reason refraction actually happens. So shorter wavelengths bend or refract more. So the violet light, because it's got a shorter wavelength and a higher frequency, it bends more than the red light, which has got a longer wavelength and a lower frequency, which bends less. And this is why we split out the spectrum as so. And this pattern continues. So I'm going to change colour just to make it a bit clearer. As we go down from red to violet, the wavelength of the light decreases and the frequency increases. So red light has got the longest wavelength and the lowest frequency. Orange light has got a slightly shorter wavelength than red light and a slightly higher frequency than red light, and it carries on until we get to violet light, which has got the shortest wavelength and the highest frequency. Now, if we can split white light up into the visible spectrum, or we can split white light up into colours, it stands to reason that we can also mix those colours and make white light, and we can. So mixing light is the reverse really of splitting up light, and there are 3 primary colours of light, and they're going to be in these big circles here. These 3 are the primary colours. Now in art you would expect those primary colours to be red, yellow and blue, because you use those colours, you mix them together to make different colours. So red and yellow make green, red and blue make purple, etc. In light it's a little bit different. 2 of them are the same. We do still have red. So red is one of the primary colours of light. We do still have blue, but our other primary colour isn't yellow, it's actually green. So that's a bit of a difference. So the primary colours of light are red, green and blue. Now just like in art, when you mix the primary colours you get secondary colours. We do have secondary colours in physics, and there are 3 of them. And you might have had these before on your printer. Now if I mix red and blue together, I get a kind of purple, and this purple is called magenta. If I mix red and green together, I actually get yellow. And if I mix blue and green together, I get a pretty nice colour called cyan. And these 3 colours are the colours that you'll see on the ink inside a printer, and they combine to make all the colours that we need when we're printing. But when we have light, we have to go for the primary colours and mix those together. Now you may notice that in the centre I've not coloured anything at all, and that's because in the centre all 3 primary colours are mixed together. Now if you did that in art you'd get a brown kind of murky mess, but in physics what do you get when you mix all the colours of light together? You get white light, proving that white light is made of a mixture of colours. And it's basically the opposite of dispersion, where we've taken white light and split it up. Here we've taken all the colours and we've put them together to make white light.